let's take a look at a few more definition of the derivative problems here. And this time I'm given f of x equals to this cubic function here. And step one is, what does f of x plus h, what does that really mean? Well, if I take a look at the original function, it just basically means all the x's are replaced with x plus h. So in our first limit statement here, so I'll write out the limit as h goes to 0. I have bracket x plus h, and that's being raised to the power 3, minus 2 times, and then not x, but bracket onto x plus h. And then when there's a minus sign in the definition of derivative formula, so there's a minus there, and then we subtract the original function, and the original function is just x cubed minus 2x. And then we divide that whole thing by h. All right, so that's step number one. We have to make sure that we insert the function correctly into the definition of derivative. When we're doing this problem here, I would say that this part of the problem is going to create the most amount of work. So if you're watching the homework help guide here, I would actually spend a few minutes watching the next few steps instead of writing out every single detailed algebra step here. But if I expand that by 3, it looks like this, x plus h times x plus h times x plus h. So if I raise to the power 3, that binomial will be expanded 3 times. Then I would go ahead and FOIL this part here first, and if you FOIL that part out, you get x squared plus 2xh plus h squared, and then all of that gets multiplied with x plus h. Okay, and then we erase all that, and then we FOIL one more time here, so this times this gives you x cubed, and then plus x squared h. And then if I now multiply this with this, if I take the middle term, the 2xh times that, I get plus 2 x squared h plus 2x h squared. And then finally this last one, if I multiply that with that, I get positive x h squared plus h cubed. Okay, so that's looking pretty good there, so quite a bit of work there. And if we go ahead and collect like terms, I see the second and third terms here, we can definitely combine that. So if we combine those, we get x cubed plus, and then there's a 1 here and a 2 there, so 1 plus 2 is going to be 3, so 3 x squared h plus, and then if I add the 2 and the 1, 2 plus 1 is going to be 3, so I have a 3 onto x h squared, and then plus an h cubed at the very end there. Okay, so that's the amount of work it takes to kind of FOIL out that part there. And I guess what I'll do here is maybe I'll write the limit statement here. The limit as h goes to 0 of all of that. And then over here I have a minus 2xh, right? So I minus 2, and then we distribute that onto everything in there. So if I do that correctly, I get negative 2x minus 2h. And then if we distribute this minus sign into the brackets here, I get negative x cubed plus 2x. Right, so there we go. Now what we need to do next is we need to kind of clean up the numerator here by collecting like terms. So I have this piece right here and that piece right there. And is there anything else that we can cancel off? Yep, there is. There's a negative 2x right here and a positive 2x right there. So let's go ahead and just cancel those terms off. So I can erase this and this, erase that, and erase that. Okay, so and then maybe the negative 2h I'll just move over. Okay, and then on the numerator now, we can factor out, every single term has an h, right? So we can definitely factor out an h. And then if we factor out the h, we get 3x squared plus 3xh plus h squared minus 2. And then close the bracket there, all divided by h. And then I have the limit sign here as h goes to 0. And then I have this h here and this h here. I can cancel that off. Great. And then I can erase all that. And now we finally have a substitution step here. So that goes into there and that goes into there. And when we substitute 0 there, I guess this term and this term will go away. And now we're left with just 3x squared minus 2 as our final answer for that derivative. Okay, let's continue on with the homework video guide. And now we're moving on to the next question here. I believe this is question number 5 here. So another definition of the derivative type of problem here, and I'm going to highlight the x in the original function because I know that x will be replaced with x plus h when I plug that function into the definition of the derivative. So let's start off by writing out the limit statement. The limit as h goes to 0, and I have 1 over the square root of, well, not x, but I have x plus h, and then a minus sign, and then I need to subtract the original function, and this is my original function right there, so that's 1 over the square root of x, all divided by h. Okay, so we've seen these limit problems before in chapter 2 here, so we're going to do the crisscross smiley face method here. So I have this root x, and that's going to multiply over here with the 1, so that's going to be 1 times root x, which is root x, and then minus, and then I will go over here now, and then I have the root of x plus h times 1. And then once we do the crisscross there, then I can take this denominator and multiply with that denominator, and if I do that, I get root x plus h times root x, and this is all being divided by h, but we know that the h can actually just come up there, so what I'll do here is I'll park the h over here like that, and then erase all this, and then I'll write my limit statement over here as the limit as h goes to 0. Okay, and then from there, I'm looking at the numerator there. There's a minus sign separating those two terms. So what I'll do next is I'll put this in a bracket, and I'm going to multiply the top and the bottom by the conjugate. So this will be root x plus the square root of x plus h. That's the conjugate expression right there. And then if I multiply the top by the conjugate, I can multiply the denominator by the conjugate as well. Okay, so what we'll do here is let's just see if we can do this all in one step without writing additional lines here, right? So let me just kind of extend the line here. Okay, so the denominator we can just leave alone. I don't think there's anything we can do with the denominator there. What we're going to do is we're just going to multiply the numerator there, because all we're doing with the conjugate piece is we're taking the first times the first. So root x times root x is going to be x. And then we multiply the last terms, which is all of this, negative the square root of x plus h times positive the square root of x plus h. And if we multiply those two expressions together, we get a negative, and then bracket x plus h, right? And then if we distribute this negative sign on, we get x minus h, and we notice that this x and this negative x cancel out, giving you just a negative h. So it turns out that if we just erase all of this now, the only thing that survives on the numerator is a negative h. All right, so this is the thing that survives on the numerator there. Okay, after that, I noticed that there is an h here and an h there, right? So technically, because all we're doing is we're multiplying all of this together, we can definitely cancel this and cancel that. So let's do that. And now we have a 1 on the top there. Okay, we're almost done here. Now we have to do the direct substitution step here. So anytime you see an h, all the h's just go to 0. So I have a negative 1 on the top. And on the denominator here, I have just root x times root x. And then I have my red brackets here. I have root x plus root x. Okay, and I guess if I multiply this and this, I get negative 1 all over. Root x times root x is just x. And then inside the brackets there, all we're really doing is we're just adding the coefficients, right? So 1 plus 1 is going to be 2, so 2 root x. So this answer is totally okay. I guess the back of the book just multiplies those two terms together. And if I do that, 2 times x is just 2x times root x. All right, so there you go. There's a few more practice questions to work with when you're dealing with the definition of the derivative.